Yeah, another DraftPhysics.com video presentation. Should be recording, but we better check. Little bugs now and then. Okay, she's working properly. So, yeah, we'll do some more kinetic energy. Play a little Professor Lewin. Try to go a little deeper. Okay, and explain some things. But to what purpose? Because there's no point in explaining to people who don't want to hear the explanations, who really aren't curious about the truth or fixing any unanswered questions. They're just religious people. They don't even want to bother reading the book. Just tell me what the general story is, and I'll live by that. It's just bandwagonism, blah blah blah. So anyway, whatever this is, a troll, no doubt. Jahannanam. Kinetic energy and momentum are two different things. I mean, it's an idiotic and ludicrous premise right from the start. It can't mean anything to anybody who's done any research, knows anything about the history. No, they're definitely the description of exactly the same thing. What's the impact? What's the meaning of something's movement? They're both giving you the answer in units. And the units are the same units in the sense that the units are made out of each other. A joule is defined by a stick of butter falling 1 meter. It's the amount of energy and produced, the amount of weight. It's exactly what kinetic energy claims to be stating, is the units of energy. Watts, joules, whatever you want to put it into, horsepower, and they get two completely different answers in 95% of the time. The answers aren't the same answer. Once a day, the clocks match, the broken clock and the working clock. One of them is a correct answer, one of them is an incorrect answer. That's exactly what the history indicates the whole function was to replace Newton's mechanics, even though Newton's mechanics worked perfectly. And it's replaced for religious reasons. That's what you're defending. There's nothing else here. You won't address the history. You won't address the facts. You'll just keep preaching your fable. Now, that's fine. That's what religious kooks do. They just keep saying God loves me over and over again. And yeah, okay, there's nothing I can do. You're irrational. You might as well be called crazy as far as I'm concerned. You were obviously raised by pigs. There's nothing I can say. Anyway, and are used for different purposes. Just an idiotic, ludicrous, completely unfounded statement. There's only one purpose. How many units of energy does it have? What's its capacity to move things in the environment? Period. They give completely different answers to that question. Fact. So you won't acknowledge facts. You just sit there and keep pretending God exists because he told me he does. I can't help you. You're too stupid. All right, that's why they have different equations. I mean, too stupid. They have different equations again because a religious nut didn't like what physics was saying. That's why there's two different equations. There's no other reason. There's no other reason than people with ulterior motives to change physics because physics was too physical. Wasn't magical enough. That's the history, shithead. I mean, all right. So I thought I reasonably replied to absolute nonsense. I endeavored to persevere and just said, okay, let's play along. All right, they may be different words, but they can't sensibly be described as different things. This can't be done, okay? The equal sign is supposed to be the same thing. Both of them are saying it equals this. Okay, and this is the same exact quality in the universe, the same exact identifier. When elements of matter move, it's called energy. So I'm just trying to point out that's the word we're using now. Newton used quantity of motion, but now we've converted into one word called energy. The energy can only have the dimensions of mass and velocity, and that's what the energy is made out of, is mass and velocity, and all you're doing is saying the velocity is squared for no good reason, again, because religious people didn't like physics. Okay, the two equations describe different universes. Just a fact. The models are entirely different. The universe comes out entirely differently if you run it on momentum or you run it on the kinetic energy formula. The two universes will not do the same thing. Okay, and are not in any way compatible because they get exactly different answers to a simple question. You ask 2 plus 2, one of them says 4 and the other one says 8. Okay, they're not the same answer. Okay, you can't show any physical experiments. So again, this is the part where they're just, I'm just going to ignore everything you say. You can't show any physical experiment where anything more than momentum is transferred from one object to another. Just a fact, you have no experiments demonstrating the existence of kinetic energy. The history indicates kinetic energy is a nonsense, and so do the experimental facts. So if you have any integrity, you give a shit about the truth, you have to concede, right? There is no evidence for kinetic energy. It was just a delusion of people hostile to austere physics. They didn't like physics that didn't have lots of gods in it. All right. So he responds by completely ignoring what I've said. Okay. All right. Why is it that some people cannot accept that they don't understand something? So, yes, why are you an asshole? It's a valid question. Something made you an asshole. I'd say it was, it's either your crack whore mother or your deadbeat, lazy fuck, child molesting father. I don't know. I mean, obviously somewhere somebody taught you being a lying sack of scum was, winning. Like that's the way to live your life, is have no integrity, argue from crap, drive too fast, throw litter out your window. You're a piece of scum. And I don't know, there is a cause to the effect. And yes, it's always easiest to blame the parenting. Frankly, your parents must have just plain sucked as human beings, had no character at all. Because it converted you into a lying sack of shit. I mean, you're just sitting here ignoring the facts. The history's not on your side, right? You can't explain to me how the history has any integrity because there's no part of the history that has any integrity. None. None of the experiments have any. Go ahead. Are you going to keep saying that clay is a great way to observe energy? That it tells you the truth? Is that what you're going to argue? That your ferrocell is the truth? That the light is being bent by the magnetism? Are you going to make that silly argument? No, you don't even have the courage to do that. You're so lame. Anyway, it turns the learning process into an impossible uphill struggle. That's right. Asshole is ruining the game. And the fact that intelligent people, that is people that have some education, seem to be just preposterous assholes, have no integrity at all. Couldn't give a fuck about the truth. Just care about how much are they getting paid, how much can they weasel out of this, how much fame or glory can they squeeze out of everything. They don't give a fuck about the truth. All right, just ask yourself this. Does knowing the momentum of an object tell you whether it's going to hurt? So he thinks this is good science. Okay, hurt when it hits you or not. Well, if you ask an insect, okay, he'll get a different answer. So the fact is, insects are made for, they're more resistant to high velocity impacts. And they don't do too good when heavy things hit them. Okay, we're the other way around. We can take slow things, take quite a bit of pressure. But fast things, yeah, they break the adhesion between our particles. So yes, we're made for a world where things move slower. Where in other environments, things are made, okay, to resist things that are going faster. Now, that's just a fact. Okay, you can't understand. That's not about it's not about the vulnerabilities of the human form. It's not about how much are we like clay. If you have any understanding of physics, you understand there's a certain amount of units of energy. See, there's this idea of quantizing. You see, and the quantizing is of the actual energy. That's what quantum mechanics actually means. Is that the energy is quantized. It's in little clumps. And all there is how many clumps. And you get more clumps if you have more mass, you carry more clumps. Okay, and the more clumps you carry per piece of mass, the faster you're going. But it's just a volume of energy. And it really just means that from our perspective, we're more vulnerable to the single piece of mass moving very fast than we are vulnerable to a whole bunch of mass moving slow. The answer is no. Whatever. Minus A1. 1 kilogram hitting you at 1,000 meters per second has the same momentum as 1,000 kilogram car hitting you at 1 meters per second. A 1,000 kilogram car. So he's keeping it in kilograms. You know, we've already done the dime and soda bottle analogy. And frankly, it's ludicrous. It's like you thinking the recoil of the gun isn't equal to the bullet's momentum, when of course they have to be equal by your own physics. So you don't like Newton's physics at all, right? Because you don't think the third law works either. It's the same amount of energy. The barrel of the gun, the stock of the gun, is moving with the same momentum as the bullet. You don't have different momentums. That's Newton's third law. Oof. Anyway, so because one looks more impressive, like it can go through things, you think it has more energy, but that's not the truth. If I do this 10 times, guess what? It's the same as doing this once, okay, in terms of energy. That's right, because the velocity is in a different package. Now, the irony is this comment is on the video where I just explained all this, right? I mean, I just drew pictures of it. What is energy? You know, the sensible answer. So this is a little bit more simple version of it, where I didn't go into quite as much detail. But it's still just an idiotic statement. All right, anyway. Okay, the former will kill you. The latter will nudge you. So again, he thinks that's rational good physics. So isn't that just as simplistic and silly as all the earth science of the Bible? You know, I mean, aren't you just reaching so hard for rationalizations to sit there and say we're going to use, you know, human sensibilities to detect the truth, when we know our sensibilities don't do that very well? You know, we don't hear all the sounds. We don't see all the light. All right, the difference between them can be expressed easily in kinetic energy. 500,000 joules versus 500. And that's the ludicrous part, right? Because right there you're just saying, I don't care about Newton's third law. He's just overtly saying it. He's saying the same explosion won't create the two events, when exactly the same energy will create the two events. The fact is, I use the same amount of explosive to move a dime 1,000 miles an hour as I do to move 2 kilograms at 1 mile an hour. It's the same amount of energy required to do it. The same gun produces the bullet and produces the gun's motion. And you're too stupid to acknowledge that well-tested fact. The cannon shoots the cannonball. The cannon moves the cannon, and the boat get moved by just as much, okay, momentum, energy, as the cannonball. Yes, the cannonball has it in a little thing. So that's the subject. And I went over that a little bit in yesterday's video, but I'll go into it some more in this video. Just to point out how you have to, the simple thing that physics is missing. See, they're doing this particle thing to some extent. They're doing this way of looking at the universe, and they think the actual elemental universe works by the same rules as our universe, or the very big universe. And there's a catch to it, okay? And it's such an obvious catch that I shouldn't even have to utter these words. Somebody should have already uttered them. But, you know, let's do the trick that makes it all understandable. The simple little thing you can understand is just a simple little paragraph of understanding, and you'll get why you can't do what Professor Lewin's doing.
And what is the momentum of this one? Well, this may be the momentum of number one, and this could be the momentum of number two.
All right, so he has two things crashing into each other's vector lines of velocity and, you know, they're going to crash into each other. They have two qualities. They have their mass and they have their velocity.
The net momentum is the vectorial sum of these two.
So this is the vectorial sum is just to say which way are the two things coming in, and then you just draw a square, okay, and you'll get your answer as the hypotenuse of the two created angles.
Which is this.
Okay, so he drew the line based on the strength of the momentum. So the key point is that on the elemental universe, right, the small universe doesn't care about momentum because the small universe doesn't have any variable masses in it. So velocity entirely dictates this line. Now, what I'm trying to explain to you people, okay, is that, I should be able to draw this, right? Yeah, look at that. I can emphasize, that's the line. So that line, okay, whether it's at the, what angle it's at, right? I mean, if I make this thing heavier and I make the other thing faster, I can change where that line goes, all right? I can change it to different places based on the combination of the two momentums, the two totals. And the point it would be is that what's basically being pointed out to you is the more that line lines up with one of these players, that the argument would be that would be more and more like a bullet. So a bullet has all the energy going, with its velocity, and the idea is that velocity has to keep going in the direction the bullet's going, or the bullet's not going to go very far because it's going to lose its energy to another direction. So the more that line goes off the straight line, the more energy the bullet loses, or any object hitting another object. And that's what makes this important, is that depending on what you're using, what kind of things are hitting each other, that line will have more and more variability. Now, the key point is, see, this is for our world objects where there's friction and where things have different masses. In the real universe, the small universe, the only universe, right? The only universe that really exists. Yeah, I got rid of it. I could draw I could draw stuff. I mean, let's see how it works. Smile. I'll go over there to smile. And whenever I smile and try to seduce you, like me, don't be so hatey. How come it's not working now? Oh, that's irritating. All right. Go away. Go away. There. Okay, it went away. All right. All right, so to the blackboard. All right, so in the real universe, the elemental universe, there's just, this really simple kind of masses. Everything is the same. Proton, electron, and their masses are constant. They have the same masses. So the masses are never variable. So every interaction is with things of a consistent mass. And the bigger argument is that you can almost forget about the proton mass because it's inside the nucleus. It really doesn't do anything. When atoms hit atoms, the protons really aren't involved. The electrons are doing everything. Okay, so when there's an interaction between two electrons, there's no momentum argument. It's just about velocity. Velocity will decide whose arrow, okay, is bigger. It's just about the velocity. So what we're trying to do here is to show that any interaction at an angle, okay, between electrons, you'll do your math, right? Your extension math, where you're going to attempt to figure out, well, what's the product of that interaction, and the vectorial product. So you have to draw your vectors in proportion to the size of the momentum. So this one's supposed to be a straight line, actually. And so this one we could have the long arrow, and this one would have the short arrow. And then you would just do your little drawing here, right? And then you would just do the vectorial sum, would be this line, And so you can see that, yes, the faster I make this one go, the more the energy okay, the byproduct of the interaction will produce less and less, it'll stay in this direction. And the more energy this thing has, the more it goes in that one's direction. So when you have two objects interacting with each other, right, a bunch of atoms in this big object, right, it's just got a bunch of atoms in it, and then you have something it's hitting, you have to understand that, okay, so what's really happening on the atomic level is that these electrons, on these atoms, these electrons are moving faster than these electrons, right? That's what's really happening. So these have the long vector, these have the short vector. So when a bullet's hitting a human, for example, and even if we relativistically say the human's moving and the bullet's standing still, it doesn't really matter. You're just changing which one has the much longer vector. One of them has a decidedly longer vector is the real point. So whether it's the bullets moving or the person's moving, just doesn't really matter. And this might be a way of proving relativity to be crap, is the sense that if I make them both moving 50-50, okay, then all of those interaction angles are not going to be decisive in one direction, and you would end up losing the energy to heat. So it might be that this will actually even prove relativity to be nonsense, because it'll demonstrate that I can't proportion the velocities equally. I can't say that the bullet's got half the velocity and your head's got half the velocity, because if I do that, then the interaction between the electrons will be even, and then you won't have one of them plowing through the other. You won't have the fact that you're keeping, you'll end up having the energy dissipate in directions like this or this, right? So depending on which way it's going, you could sort of understand, depending on which way the bullet's going, whether the bullet's moving or the head is moving, you could understand that the more the head's moving, the line stays here. The more the bullet's moving, the line stays this way. But if I make both of them contributors, then all the angular interactions, that is, all the interactions that happen, not being head-on or not being at a perfect perpendicular, all the ones in this kind of angle, would end up producing results that would end up dissipating the energy because it wouldn't stay on this line anymore. All right, but let's not do a relativity argument in this video. But it's another, see, you just talk about physics and you can find more and more physics truth. But anyway, so let me just stick to this argument. So what decides whether something penetrates is entirely happening on the atomic level. And all you're really saying is that if something has a high velocity, there's a high probability that when it interacts, it's going to, the products will be tending to go in the direction of the thing with the high velocity. So you won't be going this way. You won't be having an interaction with another electron that has the same high velocity. So there won't be any real probability of the energy going this way. Okay, of the vector ending up having more magnitude in some other direction than the direction of the penetrating bullet. So as long as it's keeping something a laser beam. So you can have the energy in a form, it's in the form of a laser beam. And as long as I don't scatter the photons, as I'm going through some material, if I don't scatter them, and I keep them, generally speaking, going in this direction, I'll penetrate deeper and deeper because all my energy keeps going in the same direction. That is, when I transferred it to an atom or a piece or an electron, I transferred it to one that's going in the same direction I'm going. So it's going to keep plowing the snow ahead of me. So we're working in the same direction. So now instead of having one plow, in itself, you can understand if I plow snow in this direction, it's not going to be any good. But if I'm plowing, if the guy I gave some of my money to, let's just say, I gave him my energy, and he's plowing snow in the same direction I'm going, I'm winning because I'm not going to have to plow the snow twice. I only have to plow it once, and somebody else is doing it for me now. So as long as I keep particles moving in the same direction I'm moving, I'm going to go very, very deep into the object because all the snow will get plowed in the direction I'm moving. Where if I send somebody off in these other directions plowing snow, that's lost energy. That's not going to help me. I'm going to have to plow the snow here. Okay, all of this snow, I'm going to have to give my momentum to plow it. Okay, where if I gave it to somebody else who's plowing the same direction, it's like me keeping my money. You get that? I mean, it's a simple concept, right? If I give the energy to something that's doing work in the same direction that I'm going, you can understand that it's really, you know, I'm getting the path for free. I won't have to plow that snow. He'll do it for me. So I won't have to pay more money to plow this snow. And I won't have to pay more money to plow this snow. And I won't have to pay more money to plow this snow. But if I send them off in this direction, I'll keep losing my money. And I won't have any snow plowed in front of me. You have to be able to understand that, right? That's not that complicated. So in the elemental world, velocity is the part that's flexible. The electrons all have the same mass, so mass isn't going to be a factor in the interaction. The only thing that's going to matter is which electron has more velocity, and that's going to decide the vector. And the one with more velocity gets to keep its vector longer. It gets to keep moving product in front of it longer. So the more velocity you have, the further you're going to go into a material object. It's just a physical fact. Doesn't mean you have more energy. It just means your energy is focused like a laser beam instead of spread all over the place. So now you can have a different effect on the universe. So when we measure energy, the idea is to measure all of it, to collect all of it. Okay, not to just measure how far did it go in a piece of clay. That's childish. Okay, it's silly physics by any reasonable standard. It's you know, it's way too ABC block kind of physics. Physics is a little tiny bit more complicated than that. You know, you have to use a little more thinking. So the idea is to understand that on our big universe, we're seeing objects, but we're not seeing what they're really doing. What they really are is electrons. And you got to say, what are the electrons doing? Because they're the ones doing all the real interacting. And you can understand that if the electrons on this side, okay, have a higher velocity, okay, they're going to push their energy straighter into the object, and the low velocity object is going to lose its vector, is going to get diluted by the stronger vector, okay? So it's not going to be doing work in its direction, where this one will be doing lots of work in its direction. And that's really that simple. So again, it comes down to a scatter type argument. You can understand that heat is like scattering the energy. So when you scatter the energy, frankly, you can't use it again. You can't. It's not working towards your purpose. It's not filling your bucket. It's not lifting your weight. It's not doing what you are trying to accomplish with the energy. So the more velocity, the more likelihood you keep doing work in the direction the project keeps getting accomplished. The snow gets removed in the direction that matters. However you want to analogize it. But that's the simple explanation. So understanding that the big universe, things do have variable mass. But in the small universe, they don't have variable mass. All they have is variable units of energy. All they have is a number of force bits, an amount of force, gamma ray, X-ray, ultraviolet, doesn't matter, some kind of bits of energy, magnetism, little bits of energy pushing them. That's all they have. And all you're going to measure in the collision is how many little bits of energy are pushing the electron. And the one with more bits is going to win. And the winning means it doesn't go in friction directions. It goes in the direction that you're originally moving. It more tends to stay on that path. The faster you're going, the more you tend to stay on that path. And the slower you're going, the more your energy will likely go in other directions, because the things you'll be hitting will be equal to you, and their direction will dilute your direction. All right, so there's some real physics, real mechanical model. There will be no rational explanation for, no, that's not how it happens. That's impossible. No, there won't be any explanation for how that couldn't be a perfectly valid explanation. I can do this thing where you can just imagine, if Newton had realized, what was the atoms built out of those little particles, he would have got it in a minute. He would have said, oh, that's it then. He would have explained magnetism and gravity and all of it for you if he had just had that little bit of insight of the fact that the little bits don't have variable mass. So everything's dependent on velocity for them. But unfortunately, that's not how it worked. Like I said, if I could dig up Newton, I'm sorry to disappoint you, but he would be so on my side, okay? I mean, just for the obvious reason that Leibniz was a creep, okay? Just for that obvious reason. But, he would get it. He'd say, yes, this is real physics. And that mush is pretty much just mush. I'm not saying this isn't true. For big objects, momentum decides. But certainly there's no kinetic energy in what he's drawing. So again, let's understand he's talking about momentum as if it's a real thing. And kinetic energy is just, I can keep playing. I mean, in every one of these videos, like 14, 15, and 16, in each one of these, lectures in this period of continuous time when he's explaining physics, he keeps referencing kinetic energy as something. But he keeps saying things like it doesn't have to be conserved. He actually says the words in one of the videos. I mean, some of this I guess I'll have to play eventually. It can be destroyed. When we know, no, it can never be destroyed. It can only be diverted. So nobody should ever say the energy is destroyed because that's just right? I mean, we all should know. We can't really say no. That's just silly. Okay, energy doesn't poof and energy doesn't get destroyed. So. It's always on the move in the universe somewhere. The same energy that's moving me, the same little bits of force, were, moving the dinosaurs. It's just a fact. The same little bits. Some of them are the same exact little bits. They're still moving through the environment after millions, hundreds of millions of years. They're still doing this. When you trap them down in the ground as oil, okay, it's the same little bits of energy have been trapped there for millions of years. And, you bring them to the surface and, they're able to go fly in the universe again. Well, anyway. Okay. So let's just keep it to that subject. I'm still conversing on the AB Science video, and it's all just now they've just gotten into the ad hominem attacks, all the peripheral stuff, just showing they have no argument. So all they can do is attack me personally in some way. Just so obviously desperate tactics. It's only people who have totally lost an argument, that have to resort to that horse shit. But anyway. It's just too stupid. It's too tragic, is what it is. It's a sad truth that until the bandwagon changes direction, right? You can't change the riders. You have to change the wagon. So until the leaders of physics change their tune, the followers are just going to keep waving their number one sponge finger and doing all that horse shit. So, until OJ actually admits I killed my wife, the believers, Jay, won't give up on their delusion. It's just very sad. So anyway, ugh. You people really have no integrity at all. You can't stay on the subject, can't argue the specific subjects, you won't answer the simple thought experiment questions. You're just horrible human beings, despicable human beings. Just despicable. All right, I keep looking like there's something I have to do, and no, all I have to do is hit the button. All right. So anyway, till the next time. This has been a Draft of Physics video presentation and such.